Welcome, welcome. All right, so I thought I'd make this video to show how you guys needed to do, or what the solutions are for homework number 3. And it was these 3 questions. So it's number 5, number 6, and number 7. Okay, so what I'll do is I'm going to show you step by step exactly how to do these questions. So let's start off with the first one. And what I also have for us is, let me zoom out a little bit. Here, this is question number 5. And what I also have here are the steps, exactly the thought process I want you guys to think about, okay? Remember, it's not about like, first I do this, first I do that. The reasons and the motivations are very important for for what you do. Okay, so let's do the first question. We have 4 over 3x. Oh, whoops, wait. Okay, that's better. We have 4 over 3x plus 5 over 4 is equal to 3 over x. Now remember, game plan always is get same denominators, right? So we don't have the same denominators. So what do we want to do first? It says find the LCM, so the least common multiple of the denominators. So what are the denominators? 3x, 4, and x. And now, what is the LCM of these 3? What is the reason why are we doing this? So we can have the same denominators to simplify the rational expression, right? Remember, these are rational expressions. We want to put them together. Okay, so the LCM of 3x, 4, and x is 12x, okay? And if you're thinking how and why, well, let's see. What is the LCM of, we have 3x, 4, and x. Well, what's the LCM of 3 and 4? Forget about the x. What about 3 and 4? Well, that's 12. And what else does it need? It needs, what's the LCM of x and x? And that's just x. So all of these need a 12x. So what we're going to do is we're going to change them so they all have a 12x. Okay? All right, equals 12x, right? And now basically you ask yourself, how do you go from 3x to 12x? Well, that's times 4, right? Here you see before you had to like multiply this one and this one. Here you just need to multiply 4 to get 12x. And remember, whatever you do to the bottom, you do to the top. How do you go from 4 to 12x? Well, that's times 3x. And so this is times 3x. And how do you go from x to 12? That's just 12. And you multiply this by 12. And notice you're multiplying the reds. 4 over 4 is 1. 3x over 3x is 1. And 12 divided by 12, this is 1. So you're following the rules of math. You're allowed to do this. So 4 times 3x is 12x. We're good. So 4 times 4 is 16, right? And the 3x times 5 is 15x. And here 12 times 3 is 36, okay? So this is what we have for now. And what did we accomplish? We accomplished that they all have the same denominator. So here we go. Oh, and I wrote the LCM of 3x, 4, and x is 12x. Why? Because 3x, 4, and x, these 3 expressions are factors of 12x. Okay. Now here we did step 3. What was step 3? It says multiply accordingly, right? This is multiplying accordingly, right? You are multiplying top and bottom by the same thing. Why? To get the same denominators here. So now that we have the same denominators, what can we do? We can add the fractions because they have the same denominator, right? So we can add these 2 fractions together. So this is 16 plus 15x over 12x is equal to 36 over 12x. And now we have that idea that we want to solve for x, okay? And I actually missed a little step that I should write out. So maybe write it like a 5.5 here as a step. But here, oh, there's an x here. Here, remember, if you have same denominator, you can say the numerators are equal. And I had a student ask, Mr. G, why are you allowed to say that? And the reason why is because let's say if I have, forget all this, let's say if I have like 2x over 6 is equal to 3, actually no, that's a bad example. How about 8 over 6, right? Well, here, what you could do is you could just multiply both sides by 6, and what happens? The 6's cancel out, and you just have 2x is equal to 8. And now here, we're going to do the same thing. You could just multiply both sides by 12x, right? If I multiply this entire thing by 12x, this cancels. And then what happens here? This cancels. And notice you multiplied one thing, which was the 12x, to both sides of the equation, and now here you're just left with what? The numerator. Okay? And you're just left with the numerator. And from here, once you have this, you should think to yourself, okay, I know what to do. I'm just going to solve for x. And what do? You just minus 16 minus 16, right? So 16 minus 16 is 0. This is 15x, you bring that down, equals 36 minus 16 is 20, right? And now what? You just divide 15, divide 15. X is equal to 20 over 15, or x is equal to 4 over 3. Okay? Now, if you think that we're automatically done, don't assume that all of a sudden, because here we have to check for extraneous solutions, right? So here, are we allowed, the question is, are we allowed to use 4 over 3 as x? Can we use this 4 over 3 in the original question? And here, what is the domain of this rational expression? What can x not be? X can't be 0 here. X, well, there is no x here, so that doesn't worry. And x can't be 0 here. So basically, the domain of this guy is all real, except x cannot equal 0. Well, here, x is equal to 4 over 3. So 4 over 3 is a real number, and you're allowed to use it. Okay? So that's it. That's how you did that question. All right? Let's check the other questions. So we're done with these two. Okay. Let's see. Okay, this is one. Oh, and this is the other. Okay. All right. So now let's look at this question. The second question. So here, I have all the steps out that I wrote out for you guys. Okay. So what is the first thing we do, right? Remember, game plan, get denominators to be the same. And here, the first thing you need to notice is that this b squared minus 9 is equal to b plus 3, b minus 3. So let's just change this up a little bit. So this is b plus 3. This stays the same. This stays the same. And this is equal to 10b minus 2. That numerator is the same. But we're just going to change the way this looks. This is a b plus 3, b minus 3. And notice that what do we want to do? We want to make sure they all have the same denominators, right? Well, this has a b plus 3. What is it missing? It's missing a b minus 3. And this b minus 3 needs the b plus 3. Okay? So you see here, the LCM of this guy, and this guy is this. So that's what you want to do. So now here, let's multiply accordingly so all the fractions have the same denominator. So here, let's multiply this by a, over here. Let's multiply this by a b minus 3, and this by a b minus 3, because that's what they need, right? This needs a b plus 3, and this needs a b plus 3, okay? And this we don't even need to touch this because we already have the b plus 3, b minus 3. So here, what can we do now? Now we can just say that, well, let's see, what's b minus 3 times 7? Well, that's 7b minus 21 over b minus 3, b plus 3, right? Plus 5b plus 15 over b minus 3, b plus 3. And remember, no need to multiply these two, you don't need to, is equal to 10b minus 2 over b plus 3, b plus 3, b minus 3. Okay, so now, what did we do? We did step 3, we multiplied accordingly, so all the fractions have the same denominators. And now what can we do? We can add these two expressions and put them together, and this becomes 7b minus 21 plus 5b plus 15 all over b minus 3, b plus 3, equals 10b minus 2 over b plus 3, b minus 3. Okay? Now here, once we get to this, since denominators are the same, right, numerators are equal. And here it says show y, but remember it was the same idea we used before with that 12x, right? What did we do? We multiplied both sides by 12x and the denominators canceled. Here, what do you think the magical thing is? We're going to multiply to both sides to cancel the denominators, and that is literally whatever is in the denominator. And they both share what? They share that b minus 3, b plus 3. So I know it sounds weird. Like you're so used to, oh, I multiply 2 on both sides. I multiply 7 on both sides. Like you're not really used to multiplying a b minus 3 and a b plus 3 on both sides. But you're not breaking any rules. You're allowed, you know, whatever you do to one side, you just do to the other side. So you're allowed to do this. And look, this cancels, 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 right? So that's what I mean by since denominators are the same, the numerators are equal. So now here, what do we get? We get 7b minus 21 plus 5b plus 15 is equal to 10b minus 2. Okay, so now this just solve for b. You all know how to do this part, so try and do this by yourself or just watch along. So this is what, 12b minus 21 plus 15, that's minus 6 equals 10b minus 2, right? And then from here, you just solve for b. So you could do what, plus 2, and this what becomes what, 12b minus 4 is equal to 10b. This becomes 0. Now what, you do minus 12b, and what do you get? This becomes 0. So this is minus 4. This is equal to minus 2b, right? And then, oh, let me put it up a little bit. Okay. And then what do you have? You have minus 4 is equal to minus 2b. So you just do minus 2 on both sides. And now you get b is equal to 2, right? B is equal to 2. I don't know. For me, I always like my variable on the left side. So whatever, the same thing. But now here, if you just stop and say, okay, I'm done, please don't do that, because you have to check for extraneous solutions. Are you allowed to put b into the original? And here, let's just look at each one. B cannot be, in this question, B cannot be, let's do it in green, B cannot be 3. Here, oh no, sorry. B cannot be minus 3 here. B cannot be 3 here. And B cannot be 3 or minus 3 here, right? You can't put either one in this. And here, what did we get for B? We got 2. So you're allowed to put 2 into here, so B equals 2 is a solution, okay? All right, one more question, and then we're done. So let's put this one away. Let's put this one away. All right, where did I actually put the actual question? This one is here, this one is here. Ah, okay, here it is. All right, so this is the question. We have 1 over x minus 6 plus x over x minus 2 is equal to this whole thing. What I'd like you to do is try and do this question by yourself, okay? You know, using your skills, you can do this. If you want, pause the video. If you want to see the solution, here it is. Same idea, okay? First thing you have to notice is that this x squared minus 8x plus 12 is equal to, what is it equal to? It's equal to an x minus 6, x minus 2, right? And notice that these two things are here, right? So we have this, so that's very nice. Now, all we need to do is, what do we need to do? Find the LCM of the denominators. So you see this has the x minus 2 and the x minus 2 and x minus 6. These two are missing a piece of it. So this is missing what, the x minus, this is missing an x minus 2. This is missing an x minus 2. What is this missing? An x minus 6. And this is missing an x minus 6, right? So now multiply accordingly. So they have the same denominators. So now we have, if we multiply 1 times this, this is x minus 2, right? And this is x minus 2, x minus 6 on the bottom plus x times x is x squared, x times minus 6 is minus 6x over x minus 2, x minus 6. And here, we didn't need to change anything, right? Because they have that same denominator. 4 over x minus 6, x minus 2. And now what can we do? Same denominators, we can add. And if you, well, okay, let's just actually do it. So this is what? Combine everything together. So you have x minus 2 plus x squared minus 6x, right? All over x minus 2, x minus 6 equals 4 over x minus 6, x minus 2, right? Now look, same denominator. So the trick is to say that because the denominators are the same, the numerators are equal, you're going to multiply both sides, right, by x minus 2, x minus 6, right, x minus 2, x minus 6. And this cancels, these two cancel, this cancels, cancels, right? And now what are you left with? X minus 2 plus x squared, oops, let me write it again. X minus 2 plus x squared minus 6x is equal to 4, right? Actually, let's zoom in a little bit. Okay, that's a little better. Here, so same denominators implies numerators are equal. Show y, all right? That was the showing y. Combine like terms. So let's this side here, let's just combine the terms. X squared is here. Remember, always put in standard form. Okay, putting in standard form is always nice. X squared minus 6x plus x is minus 5x, and this is minus 2 is equal to 4. Okay, now once you get to this point, this is where you have to start understanding the reasoning behind certain things. So here, look at this. Get 0 on one side. Okay, the reason you want to get 0 on one side is to give us an opportunity to solve for x. And watch what happens, because if we do here, if we do minus 4, right? Now you have x squared minus 5x minus 6. Well, this is equal to 0, right? Now, what was the reason behind this? Because now, what can we do? We can factor. We can say what two numbers when you multiply give you negative 6, but when you add give you negative 5. And we have that, it gives us the opportunity. Okay, that's really, really important behind the motivation. You see, because if you just follow steps and say I do this, I do that, then you're not understanding what the reason was for here to here. It's for us to do this, because what are the two numbers when you multiply that give you negative 6, but when you add give you negative 5? That's x minus 6 and x plus 1. Okay? Take a second and just realize that this is it, right? Because minus 6 times positive 1 is minus 6, and minus 6 plus 1 is minus 5. So now once we have this, we're allowed to use that zero product property, which says that x minus 6 is equal to 0 and x plus 1 is equal to 0, right? And now here, x is equal to 6 and x is equal to minus 1. Okay? So now we have two values that x has two values, right? So now again, don't just stop. We have to check for what? Extraneous solutions. Now here, if you go back to the original, right? This is the original question. What's the domain of this rational expression? Here, x cannot equal what? X cannot equal 6. Okay, x cannot equal 6. So now, all of a sudden, look, we cannot use this x equals 6 in here, because you're not allowed to, x cannot be 6. You're not allowed to plug in 6 into this whole entire thing. Okay, so there you go. Automatically, this x equals 6 is an extraneous solution. We're not allowed to use that. But what about the x is equal to minus 1? You see, x can be minus 1 here. That's okay. What's the domain for this guy? This is just x cannot be 2. And here, the domain is x cannot be 6 or 2. So x is equal to minus 1 is a possible solution for this whole entire thing. So there it is. We are done. How long did that take? 20 minutes. All right. Hopefully that was a good 20 minutes. All right, I'll see you in class.